In this video, I'll be discussing about enzyme inhibitors. This will be a two-part video. At the first part of the video, I will go over heavy metals and endocrine disrupting chemicals. Then the next video, I'll be discussing about lipopolysaccharides, LPS in short, and acetaldehydes. The objective is to learn how different epigenetic factors that can slow down our bodily functions, how they can impair our pathways, and show up as symptoms that most people experience nowadays, and how to use the 3Rs approach to remove these inhibitors significantly. So if you refer to these strategy pathways over here, inhibitors are actually indicated in purple text as seen over here. Inhibitors here actually mean reduced activities. It does not mean a complete stop or zero activity. And the first inhibitors I would like to go over is heavy metal toxicity. And the 5 most commonly found heavy metals in our water, food, and soil are lead, mercury, arsenic, aluminum, and cadmium. They can become very toxic when accumulated at higher concentrations. In a normal healthy individual, small amount can be cleared through your detoxification pathway. The issue happens when the antioxidants glutathione in the transsulfuration pathway is spinning very slow, either due to low substrates or these cofactors, also known as raw materials, that we consume on a daily basis, all these vitamins and minerals, or it could be the higher need for antioxidants for other oxidative stress the body is undergoing. When someone is not detoxing very well, which can come in various forms like your urine, your sweating, your feces, it can gradually build up over time. If we refer to this folate pathway, I like to start here because this pathway resembles the waterfall analogy or the factory analogy. When the problem is not resolved in the beginning of the factory line, it will eventually cascade to a bigger issue. Do you agree? And do note that I'm putting aside all this singular nucleotide polymorphism. In short, they are called SNPs because epigenetic plays a bigger role than the gene itself. Basically, genetic is only 10% and the epigenetics is 90%. We should always focus more on the epigenetics. The genetic is just the blueprint that we are born with. As mentioned in my previous video, metafolate, which is shown here 5-MTHF, is one of the crucial vitamins to keep the methylation spinning. When you have too much arsenic and lead, it will actually slow down the enzymatic functions of this gene that produce enzymes MTHFR. When there's lesser metafolate available to proceed into methionine synthase, which is the key regulator for methylation cycle, and this enzyme is very susceptible to oxidation. And this gene has the most inhibitors as shown here, all these purple text. Not only there's heavy metals, there's reactive oxygen species, there's also inflammations and acetaldehydes, which I will be discussing on the next video, can actually shut down this gene that produces this enzyme. When the methionine synthase is blocked here, it can actually raise your homocysteine level over here. Even if someone having sufficient metafolate, the blockage here can cause what we call metafolate trapping or meta-trapping. So imagine this junction over here is like having a traffic jam. Homocysteines can have various alternative routes to go, depending on the body needs. It can either proceed up if the body really in need of SAM. Then homocysteine is converted to methionine via the PHMT enzyme. This emergency conversion route only happens in the liver and kidney. Therefore, the major route which is shown here is still the preferred choice. Homocysteines can also go south through the CBS enzyme into our glutathione or transsulfuration pathway, mainly to make our antioxidants. And when there's a metabolic shift, it can get pushed back in the reverse directions to convert back into S-adenosine homocysteine. And since SAR is a potent inhibitor of metal transferases, it can greatly impact downstream reactions that require SAM as a cofactor for many biological methylation reactions. This also explains why homocysteine is such a popular marker as an indicative of inflammations for your cardiovascular disease and other neurodegenerative disease. Because SAM is required by hundreds of metal transferase enzymes for the transfer of a metal group CH3 to perform all these various processes. If all these routes are being slowed down or blocked, homocysteine can also be converted to this homocysteine thiolactone through an arrow editing process, which is very toxic and can actually modify proteins in your body. And the PON family of enzymes, stated here PON 1 and 2, are responsible to process homocysteine thiolactone back into homocysteines because you do not want this toxic chemical to build up inside our body. Furthermore, homocysteine thiolactone has been shown to be neurotoxic and can potentially contribute to conditions like Alzheimer's disease and epileptic seizures. There's also a link on this study which you can read about in my description box below. Heavy metals can also affect your bioupstream pathway, which influence the productions of your neurotransmitters and your nitric oxide. And if we switch to this BH4, your bioupstream pathway, we can see the arsenic over here can affect the productions of your tetrabiopterin. And heavy metals like aluminium, cadmium, mercury, and lead can obstruct the recycling of this BH2, which is the oxidized form of BH4, back into BH4. Do you see where it goes? High levels of these heavy metals can affect the brain chemicals productions, and also the transportation, reuptake, and even excretion. Then the next category, we have endocrine disrupting chemicals, which includes bisphenol A, atrazine, organochloride, organophosphate, PFAS and PFOS, and phthalates. So all these endocrine disrupting chemicals can actually mimic and block and interfere with our body's natural hormones in our endocrine system. Chemicals like these can disrupt our metabolism, growth, and reproductions, and other important bodily functions. We will go through a couple of them. So let's look at this organophosphate. Although there's numerous restrictions and bans on usage, but some are still in use. And organophosphate is commonly found in pesticides, such as insecticides and herbicides used for agriculture and our home. Even flea and tick treatment for pets contains organophosphates. So we have our water, soil, air, and dust. They can be a very wonderful vehicle for organophosphates to travel in our body system. The list on the right here shows the most commonly found food that has organophosphate contaminations, such as your apple, peaches, your pear, spinach, grape, berries, as well as all these processed items such as your corn chips, your popcorn, your wheat, your cereal. Studies also show contaminations even in dairy products and meats. So organophosphate can actually inhibit the enzymes TYMS under the folate pathway, and the main task for this enzyme is to replicate and repair DNA. It also slows down this PON2 enzyme, and if this path is being blocked, the toxic homocysteine thiolactone can start to build up. So if you shift to this serotonin pathway, pesticide can also interfere with all these neurotransmitters tract receptors. The receptors is the so-called activations, and these two genes are generally expressed in various parts of our brain region. When serotonin is not being activated, you will have symptoms like depressions, less faith, you tend to be more pessimistic, and also increased carb craving. Then organophosphate also inhibits this acetylcholine esterase, which is essential to break down neurotransmitter acetylcholine in our brain. When this enzyme is being slowed down, it will lead to an accumulation of acetylcholine and cause overstimulations in our nervous system. And these disruptions can be very severe because some of the common symptoms like your nausea, slow heart rate, excessive salivations, muscle twitching and weakness can be easily mistaken and overlooked. They also affect your central nervous system, which can show up as confusion, anxiety, memory loss, or even seizures. Next, we have this PFAS and PFOS. which is a type of chemical known to repel water, oil, and stains, found in many consumer goods that can be released into the environment. These are found in your cosmetics, your personal care and household care products. Those grease-free, waterproof food packaging found in a lot of these fast food restaurants, and even in some medical devices. Non-stick pan is a huge issue. When you cook your food in those pans, PFAS can leach into your food. Your tap water also contains PFAS, and always recommend a decent water filtration system to at least filters out not only your PFAS, it also filters your heavy metals, your chlorine, and even fluoride. I did a video a few months ago talking about PFAS and PFOS, whereby high level of these chemicals can be found in certain regions of Japan. You can check out the video up here. Some of the residents there are experiencing higher rates of cancers and other diseases. Then the next one will be BPA, your bisphenol A. They're usually found in receipts, certain plastic containers such as your Tupperware, baby bottles. BPA can also be found in certain eyewear or dental fillings and sealants, whereby these chemicals can now get to contact through your skin and gum 24/7 and leach into your body system without you realizing. Then we also have Phthalates, another type of plasticizer that can be found in many consumer goods such as your nail polish, your perfumes and hairsprays. Imagine you are someone who is a hairdresser, makeup artist or manicurist that deal with all these chemicals on a daily basis or whenever you have a job. You will get exposed to them every time when you use them. There's also building materials like PVC pipes and tubings, electrical wiring, and many more. So I guess it's better to do a thorough research and keep yourself aware of all these chemicals. So in terms of the 3Rs approach, you can reduce and remove and restore. And yes, you can choose BPA free or opt for glass or stainless steel. But some of these inhibitors seems to be unavoidable. And they are so prevalent in our environment nowadays. What you really need is to detox them out of your system on a daily basis gradually. And you rely heavily on your antioxidants, glutathione, and other biological enzymatic reactions. Think of it this way. The more you expose to these inhibitors, the higher demand for your glutathione. More SAMe will be required, and more essential cofactors will get depleted if it's not sufficient from your daily food intake. At the same time, if there's constant exposure to these inhibitors, it can also further slow down the activities. So what can you do? Avoiding them is your best bet. Remove or reduce them to the lowest all these environmental toxicants and wrong food. Then support with the nutrients. Most importantly, you also have to remove other oxidative stress in your body. You can do all the above steps, but if there's still inflammation, reactive oxygen species, or other infections, you can't heal, or it might be healing in a very slow rate. Okay, we have come to the end of this video. I'll go over the other two categories, lipopolysaccharides and acetaldehydes, in my next video. There will be also a more comprehensive 5R treatment protocol that you can follow. If you have not watched the video on methylation cycle, do click here.